DGX Swarm. It's 170 teraflops in a box. On a rack, it's 2 petaflops. A 2 petaflops computer for deep learning.
Deep learning. Well, there's a lot of it here at the NVIDIA GTC 2016.
The CPU conference.
We're with Micah Bloomberg. Micah, you know a lot about this because you're involved in neuroscience and deep learning and virtual reality and all this stuff. What are your impressions so far of what we've seen?
The technology appears to be making a massive leap forward in terms of like what we saw today in the keynote was there's this brand new server that it's basically like 250 servers in one processor. I mean, it's a $100,000 machine, but that's a massive leap forward in technology. So I think realistically we are moving towards maybe first human matrix, where humans are making virtual reality that we can all plug into, that we can all around the world, we can connect with each other, we can move around in VR with our hands, and we can have realistic AI that can do amazing things like create content for us.
So we took these 20,000 images from the Romanticism era. We trained our network with it overnight. Now, after the network is trained, ladies and gentlemen, what's happening here is this. After this network is trained, what Mike is doing is simply say, draw me a landscape. Now just think about this for a second, okay? Suppose you're a human, and I showed you all these images. And the next day, I say, draw me a landscape. And that's the landscape you draw.
One of the things, to your point, we saw was that whole thing of seeing thousands of images and coming out of it were images generated by a computer.
Yeah, one of the things that they talked about was that on NVIDIA's self-driving cars, they're creating like this HD camera that's going to record all of our roads in HD, so that you could go in VR, you could drive, you could, let's say that you are planning a vacation to Europe and or anywhere in the world, maybe Singapore, you'll be able to see, you'll be able to drive in VR on the actual roads, sort of like a rehearsal for your vacation, so you can see where you're going to go, you can plan your trip, and you can do all this in high definition with the world all around you. That's the technology that they're talking about here at this conference that's going to enable us to do that. So it's a really exciting time.
Well, what was remarkable about that was their car taught itself how to drive in a month. That's, I think, better than a lot of teenagers.
It did, and it keeps accelerating. Like year after year, I mean, AI is moving far beyond what it did in the 1980s to something beyond, like computer vision is already far beyond human vision. One of the things about AI right now is that maybe it can recognize you're in a self-driving car, and it can recognize the road more accurately than a human being. It recognizes this is a car, and this is a truck, and this is a dog, and this is a cat. But when it makes a mistake, it might make a mistake like if you show it a lion and it's only been trained on dogs and cats, it might think, oh, that's a cat, or that's a dog. It doesn't have a category for a lion yet. And the human world is full of constantly, it's the bizarre domain of AI where you constantly have new situations that you've never had before. And so we have to come to a point when we realize that even if AI is better than humans at recognizing what's around it, there still comes a point when it's inevitable for it to make a mistake and think that line is something that it's not, something that it's so it's interesting to think about the fact that yes, we're going to have self-driving cars, but we don't know what mistake the AI will make. But we're still going to go ahead with it anyways as an industry, because these cars will drive better than humans and they'll make fewer mistakes than humans. That's why it's going to change our world, even though we don't know 100% of what's going to happen.
Well, and what's fascinating to me is the fact that you don't have coders coding it. It's the computer coding it, right?
So we're talking about the guy in Silicon Valley who decided to take a different approach to designing his own self-driving car. He's using deep learning, which is exactly what NVIDIA's been talking about here, to basically, it's a different approach than trying to hand code AI yourself. It's a model-free method.
And so from your perspective, the groups that you manage on the web that talk about this stuff, what takeaways do you think they'll have, whether it's virtual reality or the neuroscience part?
Yeah, so in one of my groups, like the Gear VR group that I founded, which now has 9,000 members, we talk about all the VR products that we're seeing here. It shows the 360 cameras that people are using, 3D 360 cameras, and one of my groups is called the Matrix of Knowledge. It's 59,000 members, and we talk about everything from AI to virtual reality, to that's the major focus right now. But it includes philosophy and mathematics and all branches of science, astrophysics and neuroscience. And I think realistically, we're going to see these. We're already seeing these technologies converge at shows like this, where you have on the one hand you have deep learning over here, and the other hand you have virtual reality over here. What happens when you combine the two? Well, there's so many cases, like so many companies are using AI to, for example, in virtual reality, you wear a mask, right? There's a company over here that actually will take the sound of your voice, that's all it is, and it will recreate what your face should look like in VR. So that you could talk to somebody, you can see them talking to you, and both of you could have masks on, but it's your realistic facial expressions.
Wow.
So that's how people are combining deep learning with AI. That's just one example. Another example is you show AI a whole bunch of pictures, and I mean this is already, and now it's painting pictures. We saw this in the keynote, where it's painting these amazing vistas. It's going to create virtual content. Another thing that's going to happen is it's going to create HD maps of the supercomputer that goes in your car. Is going to create an HD map of the roadway, so you can be in virtual reality and you can drive your vacation before you go on vacation. You can rehearse your vacation by seeing all the places you would go anyways, but then plan your route and see what it's going to look like when you drive here and drive there. That's a realistic use case that we're finding out about here at the GPU Summit.
Well, and it clearly, I mean, I hope there's some ethicists and stuff like that on your use groups, because there's a lot of things of just being able to separate reality from fiction. It's going to be difficult someday, isn't it?
Well, I mean, I hope. Okay, so here's the thing. I think that one thing that because I study neuroscience, one thing that human beings are really good at is categories. So humans, no matter how great the video game looks, you're going to be able to realize that the incentives and consequences are basically just consequences, whether they're positive or negative consequences in that game world are different from the consequences in real life, because that's the fundamental thing that human beings are great at is separating things into categories and realizing that. I have to disagree. I don't think that it will be confusing to know what is reality and what is not. That's essential to our cognition, that we know.
Yeah, I was thinking things like those paintings we saw. I wouldn't be able to tell the difference.
Yeah. Well, the paintings will be so good that at some point we're going to be realistically combining the brain-computer interfaces like EEG with the deep learning technology to decode brainwaves, so that we can download and upload data to our own neural nets, so that we can interface between the artificial neural nets and the real neural nets.
Wow, it makes the whole human-machine interface very seamless.
It is. It's very cool. So nice to meet you.
Thank you very much.
Yeah.